Alright, now that our basics are out of the way, we can now talk about what Ohm's law actually states. As I mentioned previously, Ohm's law connects voltage, current, and resistance. Now we're going to see exactly how. Ohm's law states that the voltage in any system is linearly proportional to the current. In other words, it's current multiplied by some constant K. Fine. This K, we know it as R, which is short for resistance. So written in an equation form, we can say V equals I times R. This is the most famous Ohm's law. That being said, we can rearrange the terms and write two other forms of Ohm's law. We can also say I equals V over R, and finally R equals V over I. In other words, given any two quantities, we can calculate third. Okay, I want to introduce another piece of science before I give you an example and tell you how exactly this is important. So the next piece of information that I wanted to talk to you about was power. We all know power as strength. Here it's the same thing, just that we're talking about electrical power. In an equation form, power is defined as the product of the voltage and the current. Its units are watts. Fair enough. We're going to use this piece of information in our example. I just wanted to put this information out there so that I'm not stuck with introducing new information at a later time. Fine. Okay, now I know what you're thinking. You're thinking this is just science garbage which you'll never use. Here's the answer. Wrong. If you've ever done any wiring in your house, you have more than likely used the concepts of Ohm's law. Alright? Now let me spend a good few minutes talking about the applications of Ohm's law, and maybe by the end of this presentation you'll start to appreciate how important Ohm's law is in our lives and why electrical engineering is such a cool major. Alright? Great. So let's put a situation. Here's a situation. Let's say you have a bulb. And this is what we know about the bulb. It is rated at 40 watts, and its internal resistance is, let's say, 360 ohms. Fine. Let's say we attach a 80 volt DC source to this bulb in such a manner the question is, how much power are we delivering to the bulb? Let me quickly say it, the answer is not that. That's the maximum allowed power that can be delivered to the bulb. We're saying under this condition, how much are we delivering? Alright, so I'm going to use a very conventional method of solving problems. Some of you might have seen it, but let's go through it. Let's write down the givens. We know we have a 40 volt, my mistake, not 40, 80 volt DC source. We also have a bulb whose properties are watts equal 40, and resistance equal 360 ohms. And we also know P equals I times V. Those are the givens. How about the unknowns? Just one, which is total power delivered to the bulb. Sounds simple enough. Some of you might say the answer is P equals I times V, and I wouldn't disagree. However, we don't know what I is. Therefore, we have to attack it a different way. Earlier today, we learned a very interesting idea, and that was Ohm's law, which connected voltage, current, and resistance. Now, to solve this problem, we're going to use two different approaches. Approach 1, we're going to find I, plug in there, and find P. So let's do that first. We know I equals V divided by R, which equals 80 volts divided by 360 ohms, which is just, let's say 8 divided by 36, which is 4 divided by 18, which is 2 divided by 9. And if you reduce it further, this comes out to 0.22 amps. Alright, now that we know what I is, we can plug this back into the power equation. So we have P equals 0.22 times 80, which equals 17.77 watts. Fair enough.